So for this video, we're going to start our discussion on something called transformations. And so first, let's get an idea of what we mean in geometry when we say transformation. Because if you think about the word transformation and you think about outside of geometry, what we might be talking about is when we take something and we change it, right? To transform something means to change it and maybe make it look different. And that's in a way what we're doing in geometry when we use a transformation. Now here's the definition that like a textbook would give you for what a transformation is. It says it's a function that maps a given figure called a preimage onto a new figure called an image. So what do we mean by saying a function? What do we mean by saying it maps something? Well, let me give you a couple examples using the figures that I have down here. So let's say I start with this pentagon. A, B, C, D, and E are its vertices, its corners. And let's say I take that pentagon and I just slide it over on my screen to right here. And what I did is I transformed that by sliding it from one place to a new place. I took its original location, its original figure, right? It's called the preimage, and I just moved it to a new place. I made it look different because it went from being right here to being right here. It didn't necessarily completely change the way it looked, it just put it in a new spot in my plane, right? And so I mapped it to a new spot. I just kind of took it and I said, hey, go from here to over here. And so that would be one kind of transformation that we're going to learn about. It's called a translation, and we'll get to more details about a translation a little bit later. But that's one example of a transformation. Now down here I have maybe a little bit more complex transformation. It's actually going to be a series of two different transformations. Because I took this star, and of course I labeled all the corners of the star so you can kind of keep track of what happens to them. And the first thing I did was I slid it over. But you can see I didn't stop there because this doesn't look exactly like this. After I slid it over, what I did is I flipped it over. So you can see the N went from being on the top and the Q and the P on the bottom to now the N is on the bottom and then the Q and the P are on top. So I transformed this shape by first sliding it over and then flipping it. So I mapped it, so the transformation I did mapped this shape from being where it's at right now, the preimage, to now this new shape called the image that's in a different spot on my plane and it looks slightly different, right? So those are called transformations. Now there are special kinds of transformations called rigid motions. And a rigid motion is a transformation that preserves length and angle measure. It's also called an isometry, so you might see that word pop up every now and then. An isometry is another name for a rigid motion. What does it mean if we say it preserves length and angle measures? Well, let's look at a couple examples of rigid motion and a couple things that would not be rigid motion. So you can see here, I have this kind of four-sided quadrilateral, this almost like arrow-looking shape here. And all I did was I take it from the preimage here, and I flipped it over, and I made it look like this. Here I have a rectangle that I took, and then I just rotated it around 90 degrees. Now in both of these instances, what you'll notice is that if I can take this shape and I can look at each side of it, I could match it up to a side length on this shape, the preimage, and it will stay the same. So when I took this and I flipped it over, I didn't change the length of this side right here. I didn't change the length of this side. It just went over right here. It stayed the same length. And the same thing for all four sides. They didn't change their length. So I preserved the length. I also preserved angle measure, meaning that if I look at this angle, that angle measure, whatever it might be, it looks like it's somewhere maybe around 30 degrees. When it went from being there in the preimage to right here in the image, it didn't change its angle measure. It's still the same measure. And the same thing happened for all the angles in this shape. They didn't change. It's maybe easier to see on the rectangle that I rotated. Each angle in this rectangle, of course, is 90 degrees, and when I rotated it, they still stayed 90 degrees. So it preserved the angle measure as well. So these are called rigid motions. Another way to think about it, maybe a more straightforward way of thinking about what a rigid motion is that if after you do a transformation, if that new shape is identical in size and shape to the original one, then you did a rigid motion, compared to what we have over here. So you can see I took, in the first example here, I took the pre-image of this arrow and I kind of stretched it out in the image. That would not be a rigid motion because I didn't preserve length. These parts right here, for instance, got longer over here. So this image is not identical in size and shape to this one. In my example of a star, I took it and I shrunk it. I made it smaller. So again, the side lengths changed. And so it's not a rigid motion because this is not identical in size and shape to this one.